Yeah, Chris, I think you can stack them, that's why. So you did a forward, but it added to your starboard. You see how you didn't just do forward? It kind of like angled, yeah. So those goals get a bit funny. Yeah, it stacks it a bit, so you kind of went a little angle, which was actually pretty ideal for that, because then we still kept up. Yeah, it looks pretty good right now. You may have to increase your speed if you start to get out of the box there to the right on the Atalanta camera. So they just called in a minor heading adjustment there. You see our actual and then the goal, and they'll super minor. This doesn't really show you very well tracking a line, so the line here and here will draw best, you know. So you can see there in Herc's meso sonar, there's kind of that terrain. Yeah, it's probably, everything here seems pretty benign anyway, but you know, as we're going starboard, because we're not forward looking at it, we just kind of keep an eye on stuff like that. Yeah. So you're going uphill, so to the northwest is uphill. Yeah, sorry, we're bearing uphill, but you're facing kind of a long contour-ish. Well, we were taking a look at the terrain, and Matt had a really good point that we launched down here, and all of this could have been funneling it, and now we're kind of out of that. Yeah, there's probably still some current, but I don't know. Yeah, yeah, and definitely. I mean, Atalanta was over here, and now it's tracked down to there, so that's yeah, yeah, good. I don't expect too much at 500 meters. It would have to be really pulled over, but you know, Raj. So we have that wind speed there kind of coming in live, but we also have this graph here. So it's relative unless we're facing into it and in DP, in which case it's kind of real. So that, the green, yeah. So we did spike up to like in the 25s for a bit. Yeah. Yeah, you can glance it up. I mean, so don't leave it up like permanently. Like they're usually looking at this stuff and this. Although right now they're not really concerned. They're just doing whatever we tell them. So in a normal, this is a bit off, obviously, but a normal operation, if we were doing this transect, Atalanta, we're moving the ship at 325. We want Atalanta to be facing 325. We want Hercules in front of, and we're all facing 325. Obviously, this is a transect, so they'd keep a heading and all that and everything, but normally they'd be wagging back and forth, and as we move along, isn't really getting behind that plane of Atalanta. You can do it, but then you got to catch up, right? Or you got to stop the ship and do all that kind of maneuvering. But so this, we're comfortable with the way that the terrain is, that we can be moving sideways just by watching Atalanta's port side scanning sonar, making sure there's no obstacles there. Hercules is an auto altitude, but Atalanta is not. So by keeping that delta depth, they're kind of automatically then keeping off the bottom, but you can see if that bright bit there that's 45 meters out happens to be real and coming towards us, then there might be a bit that Atalanta has to adjust. So that's, yeah, it's moving. Yeah, it doesn't look too hard or too tall, but this is the example of like, if we're just like, oh, set it and forget it, then we lose that, you know? Yeah, yeah. Um, you'll see that they're on Atalanta scanning sonar. Sometimes you'll see really like a square box, and that's Atalanta is actually like it's catching a little bit of it. Usually we get that on the descent, but when we're this close to the bottom, we don't typically see it. Um, yeah, so they'll sometimes let that run out and not cycle it, and so you'll have to keep, yeah. So you just keep an eye on. Roger that. Oh, just on that one, I saw it move. I wonder if it's a wrap. I think maybe we've got some kind of interference of something. We're getting some. Yeah. So I don't know what that is. Yeah, yeah. I think it would be maybe a sonar or something. Stepping on it. It's kind of weird. Yeah. So there's a control right here, which we will do while you're busy as well. So it's kind of if your hands are full, we can do that, or you can mess with it. Yeah, it looks like it.
Yeah, currently we're at Makapu on the eastern side of Oahu Island, about 5 miles offshore. Um,
Yeah, so you can see now that
yeah,
that's
we've
getting a
been
little
here
bit
for
off.
a little while,
It's
checking out the
okay for me
seafloor.
right now, but the next time you toggle an auto XY, I can do a DVL reset and that'll get you back in here. So that's just a minor see, it's really not that bad. It's like a few meters. So in this system, we currently, we don't use a total combined solution. We have raw DVL and USBL, and we just reset that DVL to the USBL manually over time. There was reasons for that historically. Now it's starting to be you know, we could entertain that combined solution a little bit more. But in the past, we had some high resolution mapping stuff that required a DVL only solution. So we kind of had that. And we also had a horrendous track link USBL situation. And now we have a great Sonardyne. So it's a little, yeah. Yeah. So yeah, when you're done this move, when you go to toggle it, we'll do a reset. Yeah, Raj. Okay. Auto XY, so then I reset. Okay, you're good to go. So you see how it snapped over? It's all good, all easy.
Yeah, we'll be heading to Jarvis later on, after, but we're currently
Yeah, it's
here
more for
outside of
training
Oahu,
purposes
and
than
we're
anything
doing
else.
a dive off the eastern side of Oahu Island on Makapu, and looking into the precious coral beds here. And so that's kind of what the plan is, and we'll be heading out
They
to
usually
Jarvis
do, depends on the mate, but
um,
for drastic ones they
when we
will.
can.
This, I just kind of, they moved, they were at 70, now they're at 65, so I'm kind of like, you know, that's not going to really affect us. Um, yeah, it's a little bit of a mixed bag. But the DP's doing great in this direction. We're really just fighting wind. That's it. Yeah, yeah, it was gusting up to 25, so. Mm. Yeah, yeah, that tracks. You get used to some of those little artifacts, and sometimes they change year to year. Yeah. Oh, there's a pink coral. We need more of those. That's what we're after. Yeah, those pink. I don't think Megan's back there, but the precious coral, hemicorallium, and yeah, she was saying it because yeah, we may not see the way that we're facing. We may not see them for measurement purposes, but seems like. Man, so that current must have really reduced because Atalanta's still tracking westward there, getting back in the pocket. So it must have been really just where we were that. Yeah. Oh yeah, there you go. Now I'm not, doesn't sound like I'm talking to myself. Sorry everybody back at home, there was someone else here. It's not just me. They're used to.
Mic check, Amber. How's that?
That's looking good, thank you.
Great.
They're sick of hearing my voice probably at this point. Yeah, yeah.
I'm bumping in a little bit towards Atalanta.
Roger. So yeah, at this speed, once this reads 0.3, which is the speed we're supposed to be going here. Let me take a look at that.
Rennie, where does this number, this Corso ground, is that coming from the DP or is that coming from? Yeah.
Yeah, that's a good question for that Grafana. Dan may know, but
Oh,
I don't know if that's calculated separate.
copy. I came in a little far.
Oh, okay, yeah, I see.
Sorry.
That's okay. So we might
We're
adjust our uh,
y-
delta a bit, but really the current's really whipping that tether out of the
yeah.
way. So it's
If
kind
you
of.
so, would you like me to come back to that line, or just stay where we are now and keep translating?
I think that's fine because Atalanta's going to move away from you. It already is, it looks like.
Okay.
So um, just come. I want to know that that's going to point 0.3. Hmm. Yeah. Bridge nav. Hey Oriel, can we confirm that the speed of this move is 0.3, or at least set it to 0.3 if it's not? Okay, if you think it's too stressed, so we won't be able to go any faster, yeah? Okay, roger that. Yeah, we'll try point 0.3 again. If it's too stressed, let me know and we'll go back to point 0.2. Thank you, Oriel. Appreciate it. Yeah.
Yeah, go ahead.
I know.
So right now we're surveying the Makapu'u coral bed, and this area is known to host a oh, there's an octopus. There's an octopus. You see it? Walking around on the bottom. That's exciting. I love octopus. It's a good, yeah, it's a good omen. So we have a high density of these corals that live in this area, and the ones that we're specifically looking for are the pink corals, the hemicoralliums and floricorallium. Um, they're called precious corals because people have put value on their skeleton because they are very beautiful pink and red color, and they have been used in jewelry making for a long time. So here in Hawaii, we have a fishery for these corals. It's not currently active, but it is a managed fishery. And so right now we're doing this survey as part of that management of this coral fishery. So we want to answer some questions about this bed, namely, how far does it extend? So when do we start to see these corals on the bed, and in what densities, what's the highest density do we see it? Um, and so we don't have a lot of time today to do a ton of surveying. So what we're doing is transecting
Okay.
across the known bed area in order to get those data points of
Okay.
here at
So
this deep end, which has never been surveyed before,
yeah,
where does the
roger that.
hemicorallium, those peak corals,
Keep an
start
eye on
to
Atalanta.
grow? And then as it gets more and more dense, we're going to try to measure a lot of these corals um, and see the size demographic. Do we have a lot of really large ones? Are there a lot of small ones? Um, what's the population like in this area? So a good resource for anybody at home who is looking at these animals and wants to figure out what they are, there's the Hawaii Undersea Research Laboratory Deep Sea Animal Guide that has pictures of every single one of these animals that we're seeing today. So the depth range is going to be in that 350 to 450 depth range. That covers the yellow and green boxes um, on the images. And if you look through the guide, you'll be able to see some of these animals in really high definition as we drive by. So I do see some hemicoralliums, some coralliums on that little rock over there. So we're starting to see some, but as we get into the middle of this coral bed, we should see a lot more. And we'll probably see less of these yellow Analapsamia. These yellow corals are scleractinian corals, so that means they have a calcium skeleton very similar to the corals you're going to see in your shallow coral reefs. And the white that you see on the ground, that's all dead skeleton material from these corals specifically.
And we're about, I think we're about around 500 meters depth.
Yeah, so you can check on your Riccofauna here, and that'll tell you what the depth is.
Okay,
It's
465.
yeah, so
I'm gonna bump in a little.
488 is the Herc depth,
Copy that.
and then you have 473 is the Atalanta depth. So the reason why there's a difference is because Atalanta is flying above us. Um, she keeps an eye on us, and right now we're flying in tandem. So Herc is just right underneath, going forward. Right here.
Co-pilot, just
Toggle
so
it
you
down.
know, they increased
No.
the ship speed to 0.3. We were at 0.2.
Where it says SPL.
I haven't really noticed
Yeah,
it
hit that one.
subsea,
There you go.
but
Now I can hear you.
just so you know. Yeah, maybe.
So there is actually very, very little light down here. So these corals do not have zooxanthellae like the shallow water corals. So they don't bleach. Bleaching is the act of the coral under heat stress expelling that zooxanthellae from their tissues. Here, this is probably old age more than anything else. This bed has been here for a very, very long time, and things get old and die as they do. And these particular Analapsamia, they don't get much larger than what we see. Other coral species that we'll see later do grow a lot larger, but this is a typical size for them. And so we could estimate their age. We can carbonate them if we were to collect a specimen. But we do know that a lot of the corals that live at these depths grow extremely slowly. So we expect corals like this to live hundreds of years, if not thousands. Mm-hmm.
I'm gonna bring my delta up 2 meters.
Roger that.
Go ahead.
Yeah, currently we're just doing a day dive outside of Makapu, Oahu, but soon we'll be in transit to Jarvis, and we should be on ocean for 4 to 5 days before we arrive. And then once we get there, we'll spend some time there and then finish up in Pango Pango in Samoa. And so we'll be aboard about 15 to 20 days. And so, yeah, it's this is just a unique one. We just came out for a quick run to check out Makapu off the shore of Oahu while we're still preparing to head to Jarvis.
I'm going to have to bump in again. I just did one more step forward here. I think
Yeah,
that
copy that.
0.3 is definitely being felt now.
Okay, roger, yeah. I see also that Mike's changed the Atalanta heading a little bit, yeah?
Yes.
Okay, roger.
We're coming up on our rock here.
Just trying to keep Herc center line frame.
Yeah, roger, roger that.
Ooh, look at this boulder. Oh, it's so cool. Wow, it looks like it's basalt. So all of the rock around here is all carbonate, like flat hard pan old reef. But this looks like a piece of basalt that like maybe came off the island and rolled down here. That's really cool. We've got lots of corals. Corals really like rocks. So they have to grow on hard substrates and they want to be up off the bottom because that's where you get more turbulent flow, which means more food comes to them over time. So you'll notice that in any place where there's a little raised area, you'll see a high concentration of corals growing. Yeah, because it disrupts the laminar flow. Like across a flat bottom, there's laminar flow, so it flows in only one direction. But when you have a feature, it starts to tumble, and that makes the current like bring more food.
Coming up 2 meters on Delta.
It's all
Roger
about
that.
food down here. Because these corals don't have any light, they can't photosynthesize. They have to eat things that they find in the water. Mm-hmm.
All right. I'll stop 17 meter Delta.
Roger that. Thanks, co-pilot.
All good?
Yeah, for me, this is my first time on the Nautilus. But I think usually they have a season where they travel and do a few different sites. So this season, they started in Honolulu. I went to Canada for a quick run up there, and currently we're doing this dive outside of Makapu, and we'll be heading to Jarvis in Samoa, and from Samoa they'll be traveling through the South Pacific up to Palau, I think. So this year's season they'll have a few sites, a few dives like this coming up over the next few months.
Yeah, it should be a really exciting field season. I'm excited for it. Going to these places, especially Palau, which hasn't really been explored in the deep sea. There has been some drop camera work done, which was done by the lab I work with, the Deep Sea Animal Research Center, and in tandem with National Geographic. They were down in Palau in the springtime and dropped these small cameras down with some bait, and that attracted a bunch of fish and sharks and
Right.
other invertebrates. And we were able to census those mobile animals in that way. So it'll be really exciting to go down with the ROV and see all the corals and other sessile animals that weren't censused during those drop cameras. And that's going to be really important to understanding the deep sea ecosystems around Palau. There's a lot of mapping that needs to be done down there too. The maps that we have are very sparse, and that's going to fill in a lot of gaps to help us with our Seabed 2030 project. Is trying to map the entirety of the world's oceans and seafloors by the year 2030, which is pretty ambitious. We hope to get there, or at least make a good progress. Right now, we've only got about 20% of the seafloor mapped. So there's a lot of exploration left to do, and that's why we're here and doing the things that we do, because there's so much work to be done.
So I guess we should keep an eye out for those big rocks. Like, that's, you know, we're not that far off bottom. We could hit that broadside.
Yeah, I've been taking a look at the mezzo here. I think that's going to be
Mhm.
our most useful.
Yeah,
This is useless right now.
it is. Yeah. What? How do you see range? 16. I see.
Yeah, that one I don't know. This is a new display for the Tritech that we usually had been using another one, and I'm unfamiliar with this, and it's not really working for me at the moment.
Gotcha.
Yeah.
Do you want me to change some things around for you, Rennie? What's going on? I know we're pushing buttons over here, so you let me know what you need.
i'a o ke kai hohonu a ole mako ike ma ke kai papa'u. Yeah. O ke ia mau i'a i ke kai hohonu noho lako ma ke la papakua ka moana a lako noho pili koke i ka ai kai me ka aina. No laila a ole wau ike maka ke ia mau mea mamua o ke ia ka maka mua o kou ike ana i ke ia mau mea like ole. Pihoi no hoi wau i ke ia. Mahalo ia o kou e nā hoa maka maka ka poe ole loha wai e hele pū me mako ke ia awakea nei.
Here, Megan, I'll zoom out on our map there. You can see where we are.
Oh yeah, thanks.
Coming up on Delta
It's
to
currently
17.
starting to approach what would have been the line between 3 and 4.
Okay, yeah, that's where we're kind of expecting to start to see corals. So
Okay. It seems like we'll have an off bottom time of about 15:45, maybe 1600.
okay,
Just to let you know, that's our cutoff. I
I'll
brought us
stop
back to
launch
point 3. It
Delta
sounds like
17.
the bridge doesn't want to go any faster than that as we are lateraling here.
okay, that makes
So
sense.
this will be our setup.
Doing good.
Yeah.
I guess I could estimate how far we can get. Yeah.
Yeah, let's see how far we can get. Hopefully to that close to 7, right?
So
Actually, yeah, most of the crew is not from Hawaii. I think there are 2 of us, 3 or 4 maybe on board that are actually live or work in Hawaii. And me personally, I'm from Molokai. And I think the rest of our crew that does live in Hawaii is mostly on Oahu. But yeah, most of the crew flew in from all over around the country to come and be a part of this expedition.
Yeah.
yeah, so we're a little behind now. We might want to speed up our.
Yeah. I was,
Just both facing forward, yeah. Yeah.
Yeah, because yeah, the current was ripping.
I just sped up a little bit, so hopefully we catch up here.
Yeah.
Oh, you are?
Yeah.
I was wondering.
Let me yeah, just call that out when you do it, just so
Okay.
we know. Yeah.
Changing heading.
Got it.
Roger. Yeah, so the tether is being blown northeast, which I guess it was, right?
It was northeast, yeah. So it's
So-
probably just a lighter current. I mean,
Oh man, I'm all backwards now. So,
what's that? This, yeah. But the subsea is like totally different.
okay, so
Yeah.
you're translating backwards now, pretty much.
Yeah.
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 I think it's trailing otherwise.
Yeah, that's fine with me. If
Yeah, it
it's
was
cool.
because the current was so strong that we couldn't actually make any more forward way. But now we're fine, so.
Okay.
And then you'll just,
Yeah. If you guys
Atalanta
are
will just
fine,
translate.
I'll finish that move on Atalanta's heading.
Yeah.
Yeah, I'm okay with that.
Yeah, Mike, another reason I like the call out is because then I know if I'm looking at
Yeah.
the mezzo that it's like totally spun around, or I will or I won't know them.
I don't want to, but but that is.
But I appreciate the theory.
Yeah, that looks more like a normal
so
ROV
the
dive.
coral fishery here is still considered a fishery, but it is not currently active. No one is fishing for the corallium corals here. But the black coral
I'm
is
gonna
still an
push
active
ahead then
fishery
if we're lined up just a little bit.
Sounds
in
good.
between the channels between Maui and Lanai. And so those are collected by hand by technical divers. So they actually send people down to collect those corals. They grow, yeah, this is too deep. We can't send people down this deep. So you have to go down in a submersible or you have to have an ROV in order to collect these corals.
And so has it been like harvested in the past, this area?
It has been harvested in the past.
Okay.
Um,
And using submersibles.
But, you know, the operations to run an ROV or a submersible is really expensive. You have to have a ship. You have to have really highly trained crew. Working in the deep sea, as if you've joined in the morning, is really, really challenging. So you have to know what you're doing and be able to plan for these contingencies of working in these conditions. The currents here are really, really fast. And so there are some days you wouldn't be able to dive in this area. But that's what the coral's like. That's why they live here.
Yeah, the Kaiwi Channel has known for its strong winds and currents.
Super strong, yeah.
Yeah. I spent some time on top sailing. We do some sailing on the Dabaho canoes. So we know we get good wind in the Kaiwi Channel all the time.
Oh, yeah, for sure. I've done other dives in the Kaiwi Channel up where there's the shelf farther north of here, closer to Molokai.
More by Ilio Point.
Yeah, and there's some really cool geology going over there because all of this area is old coral reef, and then there's also lava flow. And so if you're really interested in geology of the area and how these prehistoric coral reefs are formed and those lava flows come together, and there's columnar basalts, there's a lot of really cool geological history in that area. And that's what we went there to study. We had some geologists aboard who were very interested in the prehistoric corals and studying those, and then other geologists were really interested in the lava flows. So it was a really cool dive, but it was a very challenging place to work because we had these high currents, and over there it's not hard flat pan like we have here. but more like vertical walls, which is really hard for ROVs to work on because you don't want to be pushed into the wall,
Right, right.
and you don't want to have any overhangs because we are attached to the ship. We have things above our head that keep us safe, so we don't want to hang up on anything.
Yeah, yeah. And then, um, particularly, we're trying to find the boundaries of the precious coral bed. So we're kind of finding where it begins and end. There's a question: are we looking for anything in particular?
Yeah, yeah. So we are looking for the pink corals. They're considered precious corals because there's that fishery for them. Um, and we want to know those two things. Where does this bed start on this southern border? And how dense are these corals like in the bed? It's been a number of years since this area has been surveyed. So this is sort of answering some of those questions and filling in those gaps of what this bed is like. Because of the currents, there had been a number of dives that were not fully successful in this area. And so they weren't able to go and do as much surveying as, maybe they would have liked. But you can't just go out. It's really close to shore. It seems like it'd be easy to go and do this work, but
Yeah.
it is actually really challenging to get here, even though we can see land from
Yeah,
the
it
ship.
seems like it's right there, but yeah,
Yeah.
the current and the ocean. And
The ocean is a really tough place to work, and when you're a person that works in the deep sea, you have to keep that in mind. It can be frustrating sometimes, but at the same time, it's very rewarding when we,
yeah,
overcome all those obstacles and
and
get to do this
do
really
what you
cool
need to
work.
do. Yeah, awesome. And what kind of fishes? Those kind of fishes swimming by?
Uh, I think that one is a polymixia.
Because somebody asked if we ever see these along near the shoreline, the types of fish we're seeing here. There was a question in Hawaiian. I think I answered like it's not. We don't see them.
No, no, all these fish are adapted to live at these deep depths. So we have a variety of fish. The one that's on screen right now is a type of rat tail fish. I can't really tell much more than that from this view, but
Yeah.
there are a number of different species it could be. It could be an Izumia or a Melicocephalus or a Ventrifossa. There are a lot of different species of fish down here. Well, you'll notice that a lot of the fish have elongated um, body forms, very eel-like, and that's made for efficient swimming. Um, in the deep sea, there's not a lot of food, and it's dark, so you don't have to do a lot of predator avoidance. You're not a tuna, you don't need to swim very fast. So you want to swim efficiently for as long as possible and conserve as much energy as possible. So that's why a lot of those fish have that body form. But we're still relatively shallow here, so we'll see other types of fishes um, that have your more traditional
Hey Megan, just
fish
interrupting
shape.
real quick. We had to pause right here.
Okay,
We had the ship slow up, but we're resuming that shortly, so there'll be a pause.
we're going to video transect. We're video transecting. Yeah, well, we also see scorpion fishes. At the beginning of the dive, we saw some goose fishes, coffin fishes. They're a type of angler fish. They're ambush predators that like to sit on the bottom. They got that really, really sweet smile that only a mother could love. And another fish that I've seen a lot of are the green eyes. They're the little ones that are sitting on the bottom and they have the stripes on their body. They're called green eyes because their eyes are kind of iridescent green when you zoom in really close.
So, Megan, you mentioned the elongated body. Are there some other adaptations that fishes that live down this deep tend to have?
Absolutely. So a fish that we'll see often in our screen are the lanternfish. the myctophids. They are those little small darty ones that come through our screen every now and again, and they have a couple of adaptations. One, they have bioluminescence. That's where the lantern part comes. Uh, that acts as counter shading in order to help them blend in. They're also you'll notice a lot of fishes have silver sides, and that helps them kind of also blend into their environment. When we shine light on them, it makes them very easy to see, but in the dark, it makes them harder to see. So fish will use a number of different adaptations in order to live in the deep sea more efficiently and safely. You know, not being seen by predators is a big one. Being able to conserve and hunt for food is another.
Wow, thank you.
Yeah, this sort of hardpan area is very popular with a lot of different fish, and you'll notice that when we come to overhang areas, if we look underneath them, there'll be a lot of fish hanging out there. They use those areas as shelter. And then this flat area is a really good hunting ground for them as well.
So when you say sheltering, are they more sheltering from the current, or is it hiding from predators or something else?
It's usually association and hiding from predators. Some fish like being in little nooks in rocks over others. Usually the rat-tail fish generally just swim constantly out in the open. They're much more bold, but then you'll notice like a lot of the smaller fish or the scorpion fish will just sit on bottom.
Cool.
What they choose to do, it's really up to them. They find their own niche, you know?
Lots of options.
There are a lot of options. When we go deeper, you'll see even more larger rat tails, and you'll see less variety when it comes to like the colorations of these animals. We've seen a number of like sort of silvery fish, a lot of red fish, gray fish, more colors at this depth. But when we get deeper, they tend to all go to about the same color.
There's a one fish, two fish, red fish, blue fish joke to be made here, I feel
Right,
like.
yeah. I do like to like list a whole bunch of animals. Like, oh, look at all those corals. They have so many corals of so many colors. You got purple corals, yellow corals. There's a video with my voice on the OER website of me saying a whole bunch of sponges. It was this dive that was just, it was a lot of sponges, and it's called Spongapalooza. I got really excited, and the videographer thought that was really great.
I mean, I think sponges are very exciting.
They are exciting. They're really exciting. And it was really cool. There was just so many, I was overwhelmed.
Overwhelmed with sponges.
We don't have any skates here in Hawaii, so we might have had a Plesiobaetis davisi. We see those a lot around here. They're very curious. They do like to approach the ROV. They'll like hang out a little bit. Yes, Dan? I love questions. Ask me questions.
Of course, as soon as you say this, all questions
Oh, I
left
know,
my
right?
mind.
That's like the best thing to say when you don't want questions. I'm like, yes, please ask me questions. You're like, oh no, now I'm on the spot. Well, if you see something on the screen that you want to know more about, other than the piece of garbage, I don't know.
Here's a question. What sorts of factors make an environment like a better spot for coral beds? Why do we see them in some spots and not others?
So availability of ideal substrate and availability of food are going to be your two main things. So here we have it's just all flat, very stable, hard substrate. So check one. Corals can grow anywhere here. Um, the next thing is there food? Well, food comes in forms of whatever comes past the coral colony. So you need to have good current flow, which we know that is check here. It's ripping down here, which is why we've had to change our dive plan so that the ROV can actually complete this mission today. We know that the currents here can be quite tricky and very strong. More current means that more food flows past a coral colony at any given time, and that gives them more opportunity to feed from the water column. They can't move to go to their food. The food has to come to them. So the coral polyps, they're like these little animals, and they just grab onto things with their tentacles. So like just imagine an anemone, but smaller, and a whole bunch of them. And they act together as a colony. So like if one polyp doesn't collect any food for the day, it gets fed by its friends, yeah. So they all work together. Oh, look, we're getting into some more stuff. See, it's getting denser. We got a lot more sponges than we've seen before. These look like Poecilastra, a type of demisponge. And we got the yellow Enelopsomia, and then we have the purple variety. Kind of comes in colors. It also comes in white. And there's a hemicralium. You can see it's like light pink with the white edges. That's very typical. So we're starting to see the beginning of our bed here. And if I refresh our Grafana page, it'll tell us what the depth is. So we're right at there, 450.
Yeah. 450. That's the depth where they like to grow at. So we're kind of reaching the zone now.
Right, we're in the zone. So it's really depth stratified here because our surface waters are quite warm. And the temperature here, I think if I go to the temperature page, should be about 10 degrees Celsius. Science data. So I will go 7, close. So they kind of like that 7 to 10. When it gets too hot or too cold, these animals don't survive. So they are very adapted to this temperature. So in other parts of the world, say like Alaska, you might see similar animals in really shallow water because the temperature of the water is the same. You won't see these same species. They're pretty specific to our Central Pacific area, but you'll see a lot of similar species that are spread out throughout the Pacific Ocean. And we're still learning about the ranges of these species, like how far they live, what depths they live at. Every time we dive, we're getting more information about these animals and where they live and what they do. That's why we have to do this exploration. We have dove here before. We do know a lot about these animals in relation to other deep sea animals that are otherwise understudied, but we have so many more questions that need to be answered. That's just really cool formation, the way the carbonate has kind of eroded. And there you can see all the dead coral.
Yeah, that was a nice little spot. You go look underneath and see what's hiding in the crack.
Yeah, that's where
As
go
shallow
look.
water
like,
divers, we're always looking for the
oh
lobsters
yeah,
and
like all
stuff
the
in
like
the cracks.
manini are down there, and all the squirrel fishes love to hang out underneath those ledges. Um, you'll often see different types of fish hanging out there and taking advantage of those habitats.
So someone was asking about the coral business. Is it legal or kind of like, but
Uh,
you actually need equipment to get here, so it needs to be kind of,
right. It is legal as long as you do it the legal way. Um, so if you have an ROV, you have an operation that meets the standards for harvesting, and there's a size limit as well, so you can only harvest corals of a certain size, and you do have to report that to the state. So like it is legal as long as you follow the rules.
yeah, but it would be kind of difficult to do an illegal operation of this scale,
Right.
yeah.
Oh yeah. Well, we can all see you doing it
Right,
here. You know, this
exactly.
is,
Yeah, it's
anybody
it,
at the lighthouse could
it
see
takes a
you.
lot. It takes a lot to get down to this place.
Yeah. Um, you know, and it's just the cost.
Yeah.
People aren't going to pay the kind of money it would take to get here. Like a ship day can cost over, $60,000. And there are other places in the world that don't manage their fisheries. And so those areas are dredged, and the price for the product is a lot less,
Yeah,
but
yeah.
the product they get back is often
All
broken.
broken up, yeah.
Because these corals are super, super fragile. There was a dive I was on where we were looking at a coral and a fish swam in front of the ROV, and it got like a whole blindsided by the lights, and it kind of freaked out a little bit, and it swam right through the coral and shattered.
What is that over there? That
It
white
looks
thing.
like a plate.
Yeah, it looks like a styrofoam bowl or a plate or
Oh, it's probably not styrofoam.
ceramic
Probably
plate,
ceramic.
a broken plate. Yeah.
We do see that quite a bit off the South Shore. There are certain areas where the Navy ships have been, um, where there's like cups and bowls and plates on the bottom. You know, maybe some watchstanders didn't want to go back to the galley. But there are a lot of different historical artifacts that are off our South Shore. Shipwrecks from Pearl Harbor, others that have been scuttled purposefully, planes, cars, um, you know, vehicles that were both land and water vehicles. What else? Sailboats. There's lots of cool stuff.
Yeah.
And we're still finding new things.
So, hey Megan.
You
So
ready?
we're feeling a lot less current. We think it might have been some of the terrain down there was channeling it.
Okay, yeah.
So we think we have the opportunity now to face forward, but I don't know if you want to change the way your transect is being visualized.
I don't mind this way if it works for everyone.
We're totally fine to stay as is, yeah. Yeah.
Yeah, it's pretty obvious the pink corals when we see them. Like that one, that's one of them, yeah?
Yeah. You have a good eye. That's one of them.
Yeah, somebody was asking is it really obvious, or do they blend in with the dead corals? But yeah, so it's kind of,
Yeah,
you
the
can tell they're
live, yeah,
pink.
the live ones tend to have, yeah, they're like a little bit pink. Um, I don't know, they look more glowy. The dead ones kind of have a brown luster or like a really, really stark white color if they're dead. And same with the sponges, like live sponges tend to be more white. Um, if they're dead, they're brown because they get all like full of
Particles,
particles
yeah.
because the animal's no longer alive to flush all that
Flush them
out.
out.
So earlier you were talking about how corals grab their food from the current. What tends to make up that food? Like, where does it come from?
All of the food comes from the surface. So primary productivity at the surface with plankton, that is eaten by zooplankton and down the food web. Eventually you're going to have all that stuff sinking down to the seafloor. So either dead zooplankton, dead plankton, that particulate organic matter that comes down to the seafloor as marine snow is what the corals are eating.
All right.
So, you know, that food could have gone through many processes in order to get there. It could have taken many years or could have just taken a season. And some people are actually studying that using sediment traps. You can put these traps out and it captures what falls to the seafloor and you can analyze it using different methods. A lot of people use stable isotopes in order to understand the source of the flux.
Sure.
Megan, we're just doing a little management up here, speeding up a little bit during
Okay.
that transect, just to get out a little bit ahead. But
Yeah, the more we can do, the better. We like getting stuff done. I've been seeing a number of black corals. So these like little fuzzy purpley colonies. Those are black corals. So there are different species from the ones that might be collected, but there's a lot of different species of black coral. The one thing they all have in common is that their skeleton is protein-based, and it's black in color.
And then the substrate, you said that was also coral?
Yeah, it's
So
also
that's
coral.
dead corals, or is
Yeah,
it still alive?
yeah, very dead. It's
Yeah,
very dead.
very dead.
This coral existed many, many, many years ago when it was at the
Closer to the
surface.
surface. Okay.
Yeah, but with sea level change over, you know, hundreds and thousands of years, you have these carbonate shelves that get formed because the coral will all grow up to the surface and it'll be really happy. And then, you know, say sea level changes a lot, then the coral ends up dying off and the islands are consistently sinking. So over that time, that's how these shelves get down.
So this would be more like the time when the penguin banks of Molokai were closer to the surface.
Exactly. I believe that this...
Maui Nui was a big island.
Yeah, I believe this shelf is similar in age to penguin banks. But don't quote me on that.
Yeah,
It's not a geologist. But that's basically how atolls are formed. We have these volcanic islands that erupt, and the corals grow up around it, and as the island sinks under the immense weight of itself, we have the corals growing up and building the island. And eventually all of the basalt, the original part of the island, is very submerged, and it's just the coral reef making the island. And so you get the formation of atolls, which is really cool. Such a wild process. It takes millions and millions of years. So as you go across the Hawaiian Islands, they get older and older, and the chain keeps going up through the Papahanaumokuakea, up to the Emperor Seamounts. Those are all the same island chain. In the Emperor Seamounts, it actually changes direction because that was the moment where the Pacific plate and the Asiatic plate met. And so it couldn't go that way
When
anymore.
the
It
moon
couldn't
hit the
go,
earth,
yeah,
when
it,
we
could, it
spin.
couldn't, yeah, it couldn't go up, so then it had to go over.
Someone says, do you feel like you're on Star Trek as an explorer? I say, I don't know about
Oh, yeah.
Star Trek, but definitely we're explorers.
Yeah, it's kind of like being at NASA, I kind of think. We have all the screens. We're doing a lot of stuff. It's like driving a rover on Mars, but on Mars they have sandstorms, but here we have crazy
Current.
currents.
We should do a more dramatic countdown to putting the ROV in the water. Like a 10, 9, 8. Make a really big deal of it.
Yeah, if you do that every time, tell me if you're really into doing that.
I'm sure we would not get tired of it ever.
Yeah. I like to go dive, dive, dive.
It was really incredible watching the ROV get launched this morning, though. That was the first time. This is my first time dive, so that was the first time I'd seen it.
Oh,
And
yeah, that's exciting.
yeah, just the way it like dropped into the water and then started sinking. It was so beautiful.
Yeah.
Yeah.
That's really, well, because they have to thrust down the whole time, so they don't actually sink.
Huh.
They
So
have to
it
fly
was like
down.
the
The thrusters.
I don't
pushing it
actually
down.
know how the thrusters work, I'll say.
It's like a propeller.
Sure.
So it pushes the boat forward. The thrusters are oriented, when the ROV's back on deck, definitely go take a look, but they're all oriented in different directions. So you have some that are fore and aft to help you, go side to side. That's how we can move sideways, like we're doing now. And then you have your vertical thrusters, so help you go up and down.
Yeah. And I believe the ROV is neutrally buoyant when the thrusters aren't going? Or is that
It's
like
positive.
a goal? Oh, okay, it is
Yeah, it's
positive
positive.
buoyancy.
So like say we lost power, we would start floating.
Which is pretty handy, I think, in case of...
So yeah, if say in the event that the tether gets cut, the ROV would recover itself. It would come to the surface and we'd be able to pick it up.
Yeah, that sounds like a pretty nice setup there.
But you have to have enough horsepower, and so this vehicle is big enough to have that work for them. The vehicle that the University of Hawaii has, it's much more compact, and so we actually fly at negative. So we want it to be heavy so that if in the case the tether snaps, it stays on the ground. And then we go get it with another ROV.
Sure. ROVs upon ROVs.
Well, it has happened in the past. It's something that it has been known to happen. It's happened with Hercules, and it has happened with our vehicle as well. And we use another vehicle to help us recover it. When this happened to Hercules, it was not the tether, but the cables, the 681 cable that parted at the termination, which meant that Argus was acting like an anchor. So what happened was Jason, another ROV, came and cut the tether so Hercules could go swim to the surface. And then that Jason connected a cable to Argus, and they were able to haul it up.
Wow.
Yeah, it was a really fancy operation, teamwork for sure, lots of teamwork.
ROV rescue.
Yeah. Well, all of us in the deep submergence community we like to communicate with each other and collaborate. We all learn from each other. A lot of us actually work with other vehicles and other ships. So we learn a lot from each other, and it's really important to, moving forward and doing the best we can at the things that we love.
Helping each other out.
Kokua, kekahi. Yeah. Collaborative research.
Exactly.
Awesome. There's a couple fish.
Yeah, those are the green eye fish that I was talking about. They always hang out on the bottom like that.
They don't move around too much. They kind
Yeah,
of just
they
stay.
just stay. They're really cute. They've got really big
They're
eyes.
sitting right on top of the bottom,
Yep.
okay, so they're not
Yeah,
swimming
and this
above it. They're
this one
actually,
is actually a coelurynchus,
okay.
which is a type of rat tail fish. But it likes to sit on the bottom too. Though they do look very similar from that far away. It takes a lot of practice watching these videos to be able to just identify everything. But the fun thing is we have guides and things that a lot of people have put together and a lot of taxonomies that have contributed to understanding what all these animals are. And we learn new things every day. And taxonomy is always changing. There's been a lot of work with eDNA, and that's been really exciting. We've been learning more about how these animals are
Hey,
related
Chris,
or not related
your
based on
friend
their
from Okeanos
morphology.
said aloha
Okeanos says aloha.
to Chris.
Nice.
Or how do I get Chris? Which one is him? That's
I believe Chris is in the pilot position.
pilot
Pilot.
position. So we go,
Yeah, you have to hold it down to talk to him.
hey Chris, somebody said aloha from the Okeanos.
Oh, aloha, Okeanos.
Nice.
Thank you. I know those guys. And
Yeah, I've
gals.
sailed with the Okeanos a few times.
I think we sailed together, Megan.
Oh yeah, we have.
Changing heading 10 degrees starboard.
Roger.
Probably 2019, right?
Something like that, yeah.
I don't know if we have one right now. Oh, well, it's flat and it's carbonate. That was the geologist old coral reef. Um, yeah, there's some like boulders, and those probably came tumbling down at some point. Exactly how they got there, we can only speculate. The boulder ferry. That's
Hawaiians dropping rocks overboard. That one looked
right.
a little bit too big
A
though.
little too big. There's another little coelurynchus. They're so cute. I really like those guys. Though I think they're all cute, so.
Pretty good.
Changing heading 10 degrees to starboard.
Yeah, so where's that tether? Is it kind of like kiting out to the
Kiting out
northeast?
to starboard.
We've been seeing a lot of black coral.
Is that like unexpected or?
Just an
Just-
observation.
Uh-huh.
And a lot of these like little
I
sponges.
can come up if you like, yeah, just to keep it out.
Yeah, the last time I was
Coming up to
here was
1.5
in
meter delta.
2017. But we were more smack in the middle of the bed, and there was a lot more diversity. I feel like in this area, it's a little bit lower in diversity. So it should pick up as
1.5
we
meter
go.
delta.
But again, we've never surveyed this part of the coral bed area, so what we see is kind of a mystery at this point.
Yeah, it's always good to go see new places.
Of course, it answers a lot of questions. You know, we could have assumed that the area over here would be just as viable as further north, but we're not really seeing the same things. Maybe, and as we keep going, we'll fill in those gaps. Some
Yeah,
food
we'll be
for
heading
thought.
to Jarvis in the near future. We're not sure exactly when now. We gotta do some things, but we'll be there eventually.
Yeah, dives at Jarvis are always really cool. Yeah. Well, you know. Well, at the beginning of a season, it can always be a little challenging. Oh, the flip is a research vessel. It's actually really cool. I don't think any of us have.
Not that we know of.
It would be, I think it's retired now, but it would have been a really cool ship to sail on. Kind of awkward, because all of the cabin spaces go both directions. So like, especially the bathroom was a little strange, because you have like a sink here and a sink here. Like, kind of have to like think sideways sometimes.
Megan, we increased the speed, the ship speed to 0.4.
Roger, thank you.
So hopefully get a little farther. I have a feeling that, let's see, I'll do a little bit of math then. 0.5, we have maybe a little over 2 hours on the bottom. Yeah.
I was saying we should be able to get what, like, at least 2 kilometers.
I don't know if we'll make 2 for the from here on, because we got to pull up at 3:45
Okay.
or maybe 1600. So we might make it between 5 and 6. I know that's not ideal,
Okay.
but we'll see. Still haven't really seen a lot of the hemicorallium, yeah?
No, we really haven't. Like, I expected to see it by now,
Yeah.
but it's interesting.
I was going to say me too, but then I realized that that would completely based on my only information is from you, so I'm just agreeing with you.
Thanks for agreeing with me.
Yeah. Yeah, that sounds good.
Yeah, and some of the corals are, like, there are some Analopsamia that kind of come in a beige color. So when I review the video, make sure that the ones that we ID as hemicorallium are actually hemicorallium.
Well, the photos that you were showing are really quite dense.
Yeah, no, it's really dense. It's
There's a
usually
reason why
like
we're
a
here.
few per square meter.
Yeah.
This isn't as dense as that. Hopefully, by the time we get to the end, we'll be in the middle of the bed.
Yeah.
Wonder what that red thing is. It's probably garbage. Yeah.
Where was that? We passed it?
We just passed it.
Oh yeah, I see it.
Yeah, I think that might be a beer bottle.
Trash, yeah.
Yeah. Well, it wasn't a fish. It wasn't the right color for anything. But sometimes, you know, you'll watch the video and you'll see something, you'll ID it, and then you zoom in, and then it's actually trash. Like, oh, wow.
I had that. I used to work on phytoplankton identification, and I used to have that where it'd be like, whoa, that's a weird, or zooplankton, I mean, it would be like, whoa, that's a weird looking zooplankton, and it would be microplastic.
Yeah. Yeah. It happens. I love these. See the little hermit crab? It's a Sympagurus dolphini. It has this little anemone backpack.
We're usually
So
not
cute.
at hermit crab depths.
So instead of having like a shell, it carries an anemone. It doesn't have a shell. the anemone is its shell.
Do they live in shallower waters too?
That one does not.
But
It lives at these
similar
depths.
types
Yeah.
of anemone
So
hermit crabs?
yeah, generally the ones that live in shallow water, like they don't use the anemone as a shell. They like have a shell and there's an anemone on
On
the
top of
shell.
it. Okay, because
Yeah,
I remember one time I caught one in my lay net.
yeah,
I was like, I never seen any of these before, except in pictures maybe. But I was
yeah.
like,
There might
wow.
be a few species. I don't know my shallow reef animals super well. There's a lot of animals out there.
Yeah,
I
yeah.
can't claim to know them all.
Is there a reason why they don't use a shell?
They just have this really good relationship with this anemone. We don't know how they find the anemone, but this species always has this anemone. So it's a great question. We don't know.
So do we know if it's symbiotic? Like, does the anemone get a benefit from this setup?
Oh yeah, so it gets to move
Move
around.
around.
Oh, fair enough.
And
Yeah.
then crabs are a known like messy eaters.
Mm-hmm.
So they get to feed
Little
off
bits of
whatever's around,
snacks.
little
Yeah.
snacks. So the crab feeds it, brings it places, and the anemone protects the crab.
Pretty handy.
Another Coelurhynchus.
And that's a black coral next to it?
Yes, that's a black coral. It's a type of Cladopathidae, probably Cladopathes. We're starting to get into some plexaurids. Those are those whitish, yellowish ones. So now we know we're getting in the shallower water when we start to see those.
So those are alive.
Those are all alive, yeah. They do blend in perfectly
Mm-hmm.
with the ground here. Generally, they look a lot more vibrant when they're on a black background. Oh, and did you know that monk seals can dive this deep?
Wow. They cover the whole range.
Yeah. Um, the submersibles were diving over off the Kona coast and on a coral bed just like this, and a monk seal like came down and just swam in front of the submarine. It was really cool. And before that, we didn't know that they went that deep.
Do they hunt down here?
Yeah, I think so. There
Wow.
are some large bottom fish that live down here, like the snapper, and there's some grouper, and so they might be hunting those animals, or they're just doing it for fun. But it's really cool to see that. Like usually, just you wouldn't expect to see a seal at these depths.
I know, I would
But
be
they're
really
capable of
surprised
it.
if we saw one now, actually.
Oh yeah, no, that would make our day. We could stop the transect if we saw a monk seal. I'll put that out in the world. Maybe it'll summon one. Or a whale or something. There was a time, I think the Nautilus was in the Gulf of Mexico, and they saw a sperm whale. That was really cool. Do you know about this? Yeah, but those are mostly dead. Yeah, this area is really sparse. Oh, there we go. There's some coming up. This could be like a low spot in this area. You kind of see we're like kind of in a dip. And some of these corals I think are covered in zoanthids. So you see where it's yellow versus where it's like white. Those whites are are zoanthids, which are parasitic on top of other corals. And then the histosideris like to eat coral.
Oh yeah.
Oh, oh yeah, there
So
are
we had a
swordfish down
swordfish,
here.
yeah, but something came off the vehicle, yeah.
Oh, they're very aggressive and territorial. Um, there was a dive
That'd be
where a
interesting.
swordfish just completely rammed the submersible and broke off its beak in the foam. It's still there. So
We
yeah,
had someone ask for any book recommendations to get more information on
book
deep sea
recommendations.
or websites maybe.
Well, websites. The Hawaii Undersea Research Laboratory Archive is a great place for deep sea animal guide. There's a portal to all the data that's been collected um, using the submersibles and ROV, and also a little maritime heritage section where it documents all the different wrecks and things that have been found on the seafloor that were man-made. So that's a really great site. There's also the NOAA Deep Sea Animal Guide that has pictures from all across the Pacific and Atlantic. Um, so that's a great place to look for a lot of really high resolution, beautiful imagery. Um, I
I think I
also
have in my
have,
classroom in deeper waters or something like that. Is that a? I think I had a book something like that.
yeah,
In deeper waters maybe it has some pictures, but not really extensive.
but like for teachers and stuff, there's the Deep Sea Education Project, which is a great resource. You can find lesson plans for children, K through 12. Any person of any age could definitely look through all that information. It's a great place to learn a lot of different things. Um, in terms of like straight up textbooks, like what I like to read is probably not what the average person would enjoy. I usually am looking through taxonomic
Yeah.
papers and those big coffee table books of like the fishes of the world kind of deal. The last books that we bought were Rays of the World and Sharks of the World, which are great books for learning more about identifying, all of the sharks that we know about. It's the great photos, key to animals, what are the features for identifying these animals. I find that very, very useful, and I learn new things every day.
Yeah, a big part of the books I use with my students are more field guide to identification guides of our fish and
Yeah.
invertebrates, and we do a lot of frequent field trips and stuff. So this is cool to see a different side to the ocean, the bottom.
I really like the Reef Fishes of Hawaii
Yeah,
book. That one's a really
bought,
good
I
one.
buy that one and invertebrates of Hawaii as well. So we do a lot of monitoring on Molokai South Shore mostly. Of course, to catch it and eat it.
Yeah, of course. We're like, what's good? What's not good?
Yeah, our students really love to go on our field trips with the throw net and the lay net. Definitely gotta identify it and see if what they eat and if they're spawning, and then we eat them too.
Right.
Yeah.
Well, we want to make sure that we don't overtake and we don't take, animals that are currently reproducing, because that's how we get more.
Yep. Yeah, it's important that we know when they're spawning, so that we can ensure healthy stock for future generations.
Yeah, because there is sustainable take in any community. Um, by reducing the population, it makes space for more animals to grow. So by taking some, it actually helps a lot of populations. But if you take too much, it can be a real detriment to populations.
Yeah, Molokai, it's subsistence, so it's for take what we eat, and we've had a pretty good balance where we have a sustainable fishery for our families, and hopefully can keep it that way for future generations.
Exactly. I'm looking for my favorite fish. Ah, there it is. It's my favorite fish, Hilardia. It's called Hilardia goslini, and I don't know, it's just really cute. It has like this spiky hairdo situation. This one's not being very cooperative, but we'll probably see another one. They're very abundant down here.
You just happened to say that right when it appeared, yeah.
I was like, oh, I hope we see my favorite fish. I just really like it. It like has this pointy nose and this spiky hairdo. Yeah, that one is like kind of diamond shape. It's very fun. There's a bunch of urchins. Where are those hemicoralliums? Looks like another bottle. No, it's just, I think, the coral growth, and there's like erosion over time. I don't know.
Megan, we're seeing a total change of the current to now be
The other direction?
the other direction almost.
Okay,
Yeah.
what do you propose?
Oh, we're just watching it.
Okay,
It's okay right now, but the tether is now
now going,
flagging the other way.
yeah.
Yeah, and
Interesting.
Atalanta's dragging that way as well.
Fascinating.
Roger that, step into starboard.
You just never know down here.
Let's, okay.
Oh, it's an
Okay,
areoma.
we're pretty much directly over it.
Yeah.
We'll watch where that tether's settling as we.
They
So
look a lot like the green eyes, but they're slightly different.
just want to make sure that it's not getting all. Yeah, might have to, but it seems like it's just streamed well out away from everything, but it's hard to say. Once Herc gets out in front, we'll be in a better shape. Yeah, if need be, we could always. Yeah, so that matches a upslope direction. There's just probably one of those shelves again. But if need be, we can talk to Megan, and if we need to face forward in this new current direction.
Yeah, we can face forward.
Yeah?
Yeah.
Is it going to mess you up?
No, it won't mess me up.
Okay. What do you guys think about that? just going back to normal ops mode. And so yeah, so we would need to change your heading to 325. Yeah. And I think you can do that while you're still stepping. Otherwise, you could just toggle on and off, change the heading, and then drive forward, get out ahead, you know. I'll leave that to you and Chris.
Oh, jeez.
How about that one in the middle of the screen right now? We've seen that before. What are those? Those are starfish?
The purple urchin?
Yeah,
Oh, so that's the
urchins.
goal, yeah. So
Yeah,
you'll want to go to
urchins.
step is 1
Urchins.
degree, so change that step
And
under
they got
heading.
long spines or
Yeah,
flat?
from
Yeah,
1, change
so
that to
they're
something
like pencil
higher, and then
urchins. They're
click in a
related to the
couple of
pencil
heading
urchins.
steps. Yeah. So heading starboard, yeah, and then we'll just see how fast it does that.
Oh, we got a shark!
Probably
Yay!
click yeah,
He's so
click
cute.
away. But what I'm curious about is if it preserves the lateral move or the direction that it, you know what I mean? Keeping the bearing.
Yeah, sharks
I'll
are
zoom
really
in
curious. They do enjoy coming by and checking us out.
Yeah.
Any idea what kind of shark that it was, maybe?
Yeah.
It's
So yeah, so then you
they
can just
changed
get
the
your
name of
goal.
it.
It says 266, get your goal to
So I'm gonna
325.
look it up.
And it seems to be going slow enough that it's not gonna, yeah, there you go.
It's not loading.
There we go. And now when you call in steps, you'll be doing step forward. Yeah. Oh yeah, I'll toggle mic as well. I think you're force talking video on the left there, just on the far left. Yeah, yeah, there you go. All right, that was a smooth little pirouette there. Now we're still going straight on the nav screen. This is this is pod racing. We do this day in, day out.
Squalus hawaiiensis. Yes. Yeah. It is in the family Squalidae.
Yeah, sounds good.
They're really cute.
That wall,
Sounds
yeah.
like they're native to Hawaii. If that's Hawaiiensis.
Yeah, hawaiiensis. I think their name before was
very linear.
something Japan,
Okay.
Japonicus or something.
No, I think it's
But
So recent research, it's unique to Hawaii.
yeah, so this one I
Different-
believe is unique to Hawaii.
It's cool.
And I think they did that based on genetic testing. You'd have to read the paper to learn more.
Yeah.
That's usually what I do. Like,
Yeah,
oh,
yeah.
let me just
Let's
read the
go
paper.
find more information.
More information. But yeah, they tend to.
sorry, Megan. We're
enjoy
officially
these.
going forward now.
Okay, we're officially
Yeah, I
going
don't
forward.
know if
I
you
made a note
Notes, great.
saying that we're changing heading.
Cool. Look at that little fish.
Yeah, it's a little green eye.
Green eye.
Chlorophthalmus. Well, this might be a better orientation because
Yeah.
now we get more time to see each one and it gets bigger as it comes towards us. Yeah, it's one of those hermit crabs, the Sympagurus dolphini. That's a bamboo coral, but it's dead.
Okay.
But you can see this is really a good opportunity to look at the structure of the skeleton.
Yeah,
See how it looks kind of like
yeah.
fingers?
Looks like the segments of the bamboo.
Yeah, so yeah, it looks like bamboo, but like it's interesting because it has calcium carbonate like bones and then proteinaceous like bendy cartilage. So it allows the coral to have the best of both worlds. So it can bend in the current, but it's also hard. So it won't like, you know, snap, which is how it gets its name, the bamboo.
Waves in the wind.
Really fun fact about bamboo coral is it has been successfully used, it has similar bone density in its skeletal structure as our bones. And so they have been,
Replacements?
they have been able to use it as a bone graft replacement for people who can't take bone grafts from themselves or others.
Cool.
Yeah, I was like, well, that's neat. Fun fact.
I've got coral in my hand. It's
Right?
growing.
I would like, if I had to choose that, I would be like, yeah, well, please put the coral in my hand. It would be, especially for like small bones, you know, like it's the
Finger.
perfect finger bone. But I'm not sure how much other research has been done using, you know, those corals. Because again, sourcing these things would be rather challenging. But bamboo coral do grow shallower. They're not all deep living, but there are a lot of very deep living bamboo corals. And they do grow quite large. So you can see some bamboos that like have some really solid bases. And they're like the size of a small bush, you know, or like small tree, large bush. But then you'll also have, you know, kind of small species as well. But I like to think like, you know, like what if you were walking around on the bottom right now? Like how would that feel, you know? All these like, it's like walking through a little meadow. That's why we call it a coral bed. Because it feels like a little flower bed, you know, everything's kind of got its own little space. There's like a lot of space around each animal. But there have been some seamounts that we visited where it feels like a forest.
Just real dense.
Yeah.
Everything is covered. Candy. Candy. Pass it all around. Where this came from?
Check, check. Okay. Whew.
Yeah, ole mo ike ina he inoa Hawaii no ke ia mauia. No ka mea, no ka papakua ko moana, aole nui ko ka Hawaii iho ana, i ka papaku. A ka e noi paha wau i nā hoa. They're asking if they have any Hawaiian names for some of the fish we're seeing.
Some of the fish have Hawaiian names, but most of them do not. So if we do see some of our bottom fish, like the pink snapper, red snapper, um, those have Hawaiian names. But yeah,
Yeah,
a lot of these corals and other smaller fish that wouldn't be fished for don't have.
I was explaining that we probably don't fish them or eat them, and we haven't really seen them unless we've gone down in a submarine. So we probably haven't given them Hawaiian names yet. But I think that's something that might look into. The green-eyed fish. I'amaka oma'oma'o.
One of the animals that we should see today does have a scientific name that is based in Hawaiian. So that's the gold coral, which is Kulamanamana haumea.
Okay.
And they wanted to capture the essence of the gold coral, which is gold and branching.
Kulamanamana. And that's one of those bamboo corals again?
Yep, that one's an unbranched variety of the bamboo. So you'll also see bamboos that are densely branched, but we also see the bamboos in like that width variety. So we were calling those lepidopsis for the longest time, but now that there's been more genetic work in the bamboo, we started to pull back on our identification. We still have a lot to learn when it comes to the identification of some of these animals. There's actually more species than we thought, which is kind of exciting.
Yeah, anytime you go and check it out, you always find new things and keep expanding our knowledge base.
That's the great thing about exploring down here is every dive is different and new, and we learn a lot as we go along. And even in areas that have been surveyed before, we're still surveying an area that hasn't been surveyed before. It's like, yes, we've kind of been near here, but not here exactly. And if you'd asked me, this morning when I expected to see the corals of interest, I would have said sooner than now. And we're seeing a couple, so we do have a few pink corals, but these ones aren't doing so well
So
right here.
the white is not good, yeah?
That's not good. It's kind of, it's not healthy and alive. Because the pink coral has a really vibrant pink tissue, but it also has a pink skeleton. But some of the skeletons can vary in color. Obviously, the prized one is the deeper pink color. But as we go along, you'll notice that most of them are going to be more light pink. The red coral that you sometimes see in jewelry, that all comes from the Mediterranean, that deep red color.
Okay. And
that species is actually a bit shallower living than the ones here. Oh, we got a Bathypathes. That's that feather-looking coral. That's a Bathypathes.
Feather coral.
We got another two of these.
Ko'ahulu. A feather coral.
A feather coral.
Ko'ahulu.
That's a great name. Yeah, so you can just come up with all the names for them.
Got to go through a committee to get it approved first, but that one's pretty simple. A feather coral. Ko'ahulu. But yeah, e mea nui e ho'omau I ka leo nā kupuna ma na ano wahi like ole. Ha'ahe ono wau o kono ia e hele pū me ke mo poe I hiki ke malama ia ke kahi o nā kuka ana mo waino kako ma ka leo nā kupuna o Hawaii nei. No laila, mahalo ia uko e ka poe ma waho e ka poe o lelo Hawaii e holopu nei me mako ma ka nā leske ia awakea nei. E ola mau ka o lelo Hawaii.
Starting to see more coral. It should get healthier looking soon.
It's the general term in Hawaiian for coral is ko'a. And so I guess if we see different types of ko'a, we can use a descriptor. One type of ko'a is, so maybe the bamboo coral could be a ko'a ohe. Ohe? Ohe is bamboo, but yeah, I'm not sure. I'm not the one to give out names.
Yeah, naming things is kind of challenging.
Yeah.
You know, you want to make sure that you do right by the thing that you're naming, and it's important to give a lot of thought into it, which is what I've really respected about everybody who's been naming like the Papahanaumokuakea and
Yeah.
and everything, because it means a lot to everyone in the community.
Ai, oia ka mau e kuka kuka nei, he mea nui. E kapa inoa ke ia mau mea hou no mako ka Hawaii, no ka mea aia no ma Hawaii nei. A ka he mea nui, ko pono e kui, me na po e like
What's the
ole
gold
a
coral?
o la la kupono. A o he o umana e kapa vale me ke ia, a ka e mea e loa ke la mau hui e kuka kuka no ka inoa kupono no ke ia mau ia, i ka vekiu no hoi ke kai.
So that coral, the yellow one, I believe was the gold coral. So the one that we were just talking about, the Kula manamana haumeae, and that coral is actually a zoanthid, which is parasitic on other corals. So it grows on top of a bamboo coral colony, but then it creates its own skeleton, it's the only zoanthid that's known to do that. Yeah, it's really neat. And so they'll put their own skeleton down on top of the bamboo and create their own branching structure. And we're still kind of unsure as how that process occurs, but it's been dubbed the Midas process because it's turning into gold. So you'll often see bamboo coral colonies that have a small little bit of gold, and eventually, slowly over time, it'll take over the whole skeleton. And then after, these corals are known to live thousands of years. They've been dated to be, 2,000, 3,000 years old. So, the base of this, the original coral might have only been maybe an inch across, but like at the end, you've got almost like a 4-inch base. They can get really thick and they can grow a couple meters tall. So these things can get really huge.
So what is it about corals that enables them to live so long?
Oh, I don't know. But life down here in the deep sea is a lot slower. Just a lot of animals live a long time. So, here's a bamboo coral. So this would be an example of a coral that might get taken over by the gold coral. But all these animals live long lives. It's cold. There's not a lot of food. There's everything happens on a slower scale than what we're used to at the surface. And so, being able to live a long life is important in order to, continue. If you grow very slowly, resources are limiting in many places. So there's limiting food. There could be limiting nutrients in some areas, and that'll reduce your ability to grow. So if you can't grow very fast, you need to live long enough in order to get to reproductive maturity in order to keep your line going.
Sure. Whereas on the surface, if you grow very slowly, might be a higher chance that you die before you hit reproductive
Well, there's
maturity.
also animals that grow and live fast lives down here too.
True.
Sort of like these like gold corals. You can one paper that was published described it as the bristlecone pine of the deep, because it lives on the same kind of time scales that some of our really large long-lived trees live on, and they just experience time in a different way than we do. So like some of our fishes can live short lives, and some of the fishes live long lives down here. But the corals in particular kind of live more like trees. They live very slow and long lives, and they take hundreds of years to grow. So we're starting to see more of these hemicorallium, which is great. So as we pass by, and this is the gold, but this is a plexaurid. They're both yellow, but the gold is like really, really yellow. So as we go and we learn more about these animals, and we do collections and carbon dating, we've learned that like a coral this size this hemicorallium coming up could be like 100 years old to get to that size. Whereas maybe this bamboo coral